Preview.
Acclimatization. Understanding the influence of repeated daily diving on decompression stress, by Neil Pollock. While decompression sickness, or DCS, is relatively rare, it receives much attention because its effects can be severe. Divers often find themselves completing multiple dives over a short period, such as during a diving vacation. A very natural concern is whether repeated daily diving increases or decreases DCS risk. Adaptation to natural exposure is known as acclimatization. It is possible that repetitive diving could alter the degree of decompression stress experienced either through positive acclimatization, that is, protection, or negative acclimatization, which would be sensitizing or increasing the risk. Evidence of positive acclimatization to repetitive diving has been reported in a small number of animal studies, but the data is from limited work with human subjects and makes it far less clear. Few divers will repeat the exact same dive profile or profiles on a daily basis. In practice, the first dives of a series, particularly following a period of not diving or upon arrival at an unfamiliar area, are often relatively conservative in comparison with later dives. This means that any change in the risk over a series may be due to factors other than the repetitive exposure, making it difficult to study the effect purely using observational studies. A greater degree of research control is needed to gain insight. Our team recently completed a study of 4 days of identical daily diving to remove the variability of changing dive profiles. We used intravascular bubbles as the indicator of decompression stress, and the goal was to see whether post-dive bubble grade scores changed over the series. This article summarizes the research. 16 healthy, experienced, reasonably fit male divers participated in the study. All had avoided diving for at least 1 week prior to the study. Each diver completed 1 dive on each of the 4 consecutive days. Each dive was to 60 feet or 18 meters of seawater with a bottom time of 47 minutes in fairly calm, temperate ocean environments. The divers exercised continuously at a moderately heavy rate at the bottom and wore wetsuits for thermal comfort. While the depth time profile of the dive was not aggressive, the continuous exercise, which was at a higher level than most divers would maintain, increased the inert gas uptake. We have found through previous studies that this tends to generate substantially greater bubble loads with minimal risk of decompression sickness. Dive profiles and heart rates were monitored continuously and recorded electronically for all dives. Post-dive monitoring employed 2-dimensional ultrasound to allow visual study of bubbles in the heart chambers. Blood and bubbles in the right heart is pumped to the lungs, and blood, including bubbles, in the left heart is pumped throughout the body. Monitoring was conducted at 20-minute intervals for 2 hours after the dives. The presence of bubbles was scored on an 8-point scale by means of 2 experienced technicians. They were graded as follows: 0 for no bubbles, 1 for occasional bubbles, 2 for a bubble at least once every 4 cardiac cycles, grade 3 for at least 1 bubble on every cardiac cycle, 4A, at least 1 bubble per square centimeter visualized, 4B, at least 3 bubbles per square centimeter, and 4C, almost complete whiteout, but individual bubbles still discernible, and 5, complete whiteout in which no individual bubbles could be discerned. The scores were recorded while the subject remained at rest and following a standardized series of arm and leg movements. The highest score for each rest or movement cycle was used in the analysis as the peak grade for the cycle. Bubble grades were evaluated statistically to determine the likelihood or relative odds of developing relatively higher or relatively lower post-dive bubble grades. Bubble grades were evaluated statistically to determine the likelihood, that is, the odds ratio, that is, the relative odds of developing relatively higher or relatively lower post-dive bubble grades, and these were similar across the days of the study. The bubble grades were evaluated statistically to see whether either higher or lower post-bubble grades were similar across the days of the study. The results showed that the odds of having relatively higher bubble grades were lower on each successive day, whereas the odds of having relatively higher bubble grades on the fourth sequential day. The results showed the following. Using day 1 as the reference day, the odds of developing higher bubble grades were lower on each successive day. By day 4, they were about half. Using day 1 scores as a reference point of 1, the odds of developing relatively higher bubble grades were lower on each successive day. By the 4th day, they were reduced to half of the scores achieved on day 1. So what can we conclude from the study? Although bubbles do not equate to DCS, they do represent decompression stress. In this, the main finding of this study was that 4 consecutive days of identical diving appear to reduce the progressive risk of bubble production and was consistent with positive acclimatization. The controlled nature of the dive series was important to identify the pattern of change. The effect could very easily have been masked in a less controlled environment or a less controlled dive series. Although the study does suggest that acclimatization offers protective benefits, thoughtful profile choices are necessary to control the overall risk. The mechanisms of acclimatization to decompression stress are known. It could involve reduced bubble formation or a reduced physiological response to formed bubbles. It could be that asymptomatic or silent bubbles produced in tissues after decompression are responsible for a type of protective conditioning. The question of mechanisms therefore remains subject to further study. Since fewer bubbles do form, the question of mechanisms requires further study. There are subtle but complex relationships at play. The first limitation of our study is that, of course, it only represented 4 days of single dives per day. It would remain to be seen whether longer or more complicated dive series would have similar effects. The second limitation is an inability to correlate the changes in decompression stress indicated by intravascular bubbles with the absolute change of decompression sickness risk. It remains reasonable to accept, though, that the presence of fewer bubbles is desirable. So, in summary, our research helps to resolve a long, open question showing that repetitive diving can, at least in the circumstances we studied, reduce bubble formation, representing what is likely positive acclimatization to diving. Further work is required to determine if the response holds with more complicated dive series and how these changes affect absolute risk of decompression sickness.